Welcome to Raw Perfect classes. I am Dr. Rachna. In this video, I will continue previous concepts, that is threads. And in this video, I will discuss types of threads and next important concepts of this unit. Now, first point, that is types of threads. Types of threads means what type of threads which are considered in operating system. There are two types of threads. First, kernel level thread. Second is user level thread. Here I discussed its difference. Kernel level thread and user level thread. In kernel level thread, the operating system implements kernel level threads. On the other side, in user level thread, users implement user level threads. In kernel level thread, operating system implements kernel level threads, and in user level thread, users implement the user level threads. Second difference, in kernel level threads take longer to create and maintain. On the other side, user level threads may be created and handled much faster as compared to kernel level threads. Third point, if a kernel thread carries out a blocking operation, if a kernel thread carries out a blocking operation, while on the other side, in user level thread, the entire process is halted if a single user level thread carries out a blocking operation. And fourth difference, application code on kernel level thread does not include thread management code. On kernel level threads, application code does not include thread management code. It is simply on API to kernel mode. On the other side, user level thread library includes source code for thread creation, then data transfer, then thread destruction, then message passing, and after that thread scheduling. Means in kernel level thread, application code does not include any thread management code. It's only API to kernel mode. While on the other side, user level thread library, which includes source code for the thread creation, for thread data transfer, for thread destruction, for message passing, and thread scheduling. Fifth difference is system calls are used to generate and manage threads at the kernel level. System calls are used to generate and manage threads at the kernel level, while on the other side, user level threads do not invoke system calls for scheduling. And next, sixth difference is one-to-one thread mapping is supported at the kernel level. One-to-one thread mapping which is supported at the kernel level. Each user thread must be assigned to a kernel thread. And this mapping is handled by operating system. while on the other side, the user level thread is also referred to as the many to one thread. In kernel level thread, one to one thread mapping is supported, while on the other side in user level thread, many to one mapping thread is supported at the user level thread. And operating system assigns each thread in multi-threaded process to an execution context. Context switch time in kernel level thread. Context switch time is more, while in user level thread, context switch time is less in user level threads. Kernel level threads are specific to operating system. On the other side, user level threads may operate on any type of operating system. Kernel level threads may be multi-threaded, while multi-threaded applications are unable to employ multi-threads, multi-processing in user level threads. Example, Windows and Solaris. These are the examples of kernel level threads. And Java threads, POS6 threads. POS6 means Portable Operating System Interface. These are the examples of user level threads. Now, I am going to discuss next point, that is concepts of multi-threads. Multi-threading is the ability of a program. Multi-threading is the ability of a program or an operating system to enable more than one user at a time without requiring multiple copies of the program which are running on the computer. Multi-threading means it is the ability of a program of an operating system or an operating system to enable more than one user can be run at a time without requiring multiple copies of program which are running on the computer. That is known as multi-threading. And multi-threading can also handle multiple requests from same user. Each user request for a program or system service. Each user request for a program or a system service which is tracked as a thread with a separate identity. Means every user who requests for a program or system service that can be tracked as a thread with a separate identity. As program work on behalf of the initial thread, as programs which work on the behalf of the initial threads can request and are interrupted by the other requests. The work status of the initial request is tracked until the work is completed. In this context, in this state, user can also be another program. A user can also be another program. Fast central processing unit, fast CPU, speed, large memory capacities are needed for multi-threading. The single processor can execute pieces or threads of various programs so fast, and it appears the computer which is handling multiple requests and simultaneously. Now we can say that what is a concept of multi-threads? Multi-threading means, multi-threading is the ability of a program which is able to run programs more than one at a time without making their copies of program which are running on computer. And we can say that multi-threading is also handle multiple requests from same user. Every user request for a program or system service can be tracked as a thread without any separate identity. As a program, they work on the behalf of initial thread request and they are interrupted by the other request. We can say that the work status of initial request can be tracked until the work is completed. Or we can say, in this context, a user can also be another program. And fast CPU speed, large memory capacities which are needed for multi-threading, single processor executes pieces or threads of various programs so fast, and it appears the computer is handling multiple requests simultaneously. Simultaneously means at a same time, same level per. Now next point is, how does multi-threading work? How does multi-threading work? The extremely fast processing speed of today's microprocessors, microprocessor means CPU, make the multi-threading possible. Even though the processor executes only one instruction at a time and threads from multiple programs are executed so fast that it appears multiple programs are executing concurrently. Each CPU cycle execute a single thread. Every CPU cycle execute a single thread which links to all other threads in its stream. And this synchronization process occurs so fastly that it appears all the streams are executing at the same time. And we can say that a multi-threaded program is execute many threads while processing. Every thread which contains information about how it processing stream. Some threads which are executed while others wait for their turn. Multi-threading requires programmers to pay careful attention. Multi-threading requires such a programmers who pay the careful attention to prevent the race conditions and deadlock, so that there cannot be create race condition or deadlock condition. For example, multi-threading which is used in many different contexts. Context means states. One example occurs when data is entered into a spreadsheet. Spreadsheet means Excel sheet, and used for real-time application, which is used for real-time application. When working on a Excel or spreadsheet, a user enters data into cell and following may happen. Column width may be adjusted. Repeating cell elements may be replicated. Replicated means duplicate. And spreadsheets may be saved multiple times as the file is further developed. Each activity which occurs because multiple threads are generated and processed for each activity without slowing down overall spreadsheet application operation. This is the example of multi-threading, in which I have given example about a spreadsheet in which we are working in a cell. When we working in a cell, then we have to adjust column weights. Sometime when we repeat the cell elements that may be replicated, and spreadsheets which may be saved multiple times as the file is further developed, and each and every activity which occurs because of multiple threads are generated, so processed for each activity without any slowing down the overall spreadsheet application operation. Now this is the homework for you. Find two difference between multitasking, multi-threading and multiprocessing. Now next topic is process scheduling. Process scheduling is the activity of process manager. Process scheduling is the activity of process manager who handles the removal of running process from CPU and selection of another process on the basis of a particular strategy, particular policy, particular condition. And process scheduling is an essential part. What is process scheduling? It is an essential part of which multi-programming. Process scheduling is an essential part of a multi-programming operating system because operating system allows more than one process to be loaded into executable memory. At a time, and loaded process can be shared the CPU by using time multiplexing method. Now we can say that process scheduling. What is the process scheduling? We can say that it is the activity of process manager who handles the removal of running process from CPU and who select the another process on the basis of particular strategy. And we can say that process scheduling is an essential part of multi-programming operating system because in this operating system allow more than one process to be loaded into executable memory at a time, and it can be loaded process which shares the CPU which are using by time multiplexing. Now what are the categories of scheduling? Now topic is what are the categories of scheduling? There are two types of scheduling: non-preemptive and preemptive. Non-preemptive means resource can't be taken from a process until the process completed execution. Means in non-preemptive we cannot take resources from any process forcefully. We cannot take resources forcefully from process until that process can be completed its task, its execution. The switching of resources occurs when the running process terminates and moves to a waiting state. Second type is preemptive. Preemptive means when resource can be taken from a process forcefully, whether process completes its execution or not. We can say that here operating system allocates resources to a process for a fixed amount of time during resource allocation. Process switches from running state to ready state. Switches from running state to back ready state or from waiting state to ready state. This switching occurs as the CPU may give the priority to other processes and replace the process with a higher priority with a running process. Now I am going to discuss about next point, types of scheduler. This is very important point topic, types of schedulers. Types of schedulers, there are three types of schedulers which are using in process scheduling. First, long-term scheduler. Second, medium-term scheduler. Third is short-term scheduler. Now, first, long-term scheduler. Its main objective, its main motive is to maintain good degree of multi-programming. You should be keep in mind that its main objective of this scheduler is to maintain a good degree of multiprogramming. And long-term scheduler is also known as job scheduler. It selects a balanced mix of input-output bound and CPU bound processes. It selects a balanced mixture of input-output bound and CPU bound processes. Bound means restricted. From secondary memory. Secondary memory means new state. Then it loads selected process into main memory. That means into ready state for the execution. Now, second type of scheduler is medium term scheduler. In long term schedulers, main motive is to good degree of multiprogramming, while in medium term scheduler, main objective of this scheduler is swaps out the processes from main memory to secondary memory, so that free up the main memory when required. In medium term scheduler, its main objective to swapping from secondary to main memory to secondary memory. Main memory to secondary memory means to free up the main memory when required. Thus, medium term scheduler reduces the degree of multiprogramming. Medium term scheduler reduces the degree of multiprogramming. After some time, when main memory becomes available, medium term scheduler swaps in the swapped out process to main memory and its execution, which is resumed from where it left out. Swapping may also be required to improve the process mix. Swapping is required to improve. What improve? Process mix. I again repeat, what is a medium term scheduler? Medium term scheduler's main motive to swaps out that some processes from main memory to secondary memory, so that main memory can be free up when it is required. And it reduces the degree of multiprogramming. Second, after some time when main memory becomes available, then medium term scheduler swaps in the swapped out process to main memory and its execution is again resumed from where it left off. And swapping may also be required to improve the process mix. Now next point is short-term scheduler. Short-term scheduler means its main objective to increase the system performance. What is the main objective of long-term scheduler? To maintain a good good degree of multiprogramming. And what's the main objective of medium term scheduler? What is the main objective of medium term scheduler? Is to swap out from main memory to secondary memory. Swap out the process from main memory to secondary memory so that main memory can be free up when it is required. While in short-term scheduler, the main objective is to increase the system's performance. System performance means CPU's performance. It is also known as CPU scheduler. When in exam you have to ask a question, what is a CPU scheduler? What is a short-term scheduler? then you have to give answer same, because short-term scheduler is also known as CPU scheduler. And CPU scheduler, what do? It decides which process to execute next from ready queue. Which process to execute next from ready queue. After short-term scheduler decides the process, dispatcher who assigns the decided process to CPU for execution. Who assigns the decided process to CPU for execution? That is known as dispatcher. You should be keep in mind what is a dispatcher and what's the work of dispatcher. Dispatcher is that who assigns the decided process to CPU for further execution. Now it's the homework. Difference between long term, short term and middle term scheduler. You have to make a chart and write there what are the difference between long term and short term, middle term schedulers. This is one example of schedulers combinedly. Here, first of all, job, batch, queue. This is first, it is go into batch or batch queue. Then long term scheduler, which start the work, and on the other side medium term scheduler, waiting, swapped out and queue. On the other side interactive programs are also come here, and this is linked with CPU short term schedulers. When you use CPU short term scheduler, after that it will be execute or it can be waiting, go into waiting queue. This is a work of scheduler. Now next is what are the objectives? What are the main objectives of schedulers? First objective is fairness. Means every scheduling have to treat all processes as same and no process should suffer indefinite postponement. Means no process should suffer from waiting or block state. Throughput, largest possible of process or unit time, maximum number of process per milliseconds. Predictable, process should run in about the same amount of time irrespective of load on the system. On the other hand, next point is next objective of scheduling, that is resources. Keep resources always busy. Avoid indefinite postponement, priorities. It favors high priority processes. Overhead, in this portion of system resource which is invested as overhead can greatly improve performance of the system. Now next point is CPU input output burst cycle. The success of CPU scheduling depends on following property of processes. Process execution, it includes of cycle of CPU execution and input output wait. Process alternate between these two states. Process execution starts with the CPU burst, that is followed by input output burst, and which is followed by another CPU burst and then another input output burst, and so on. You can see in this diagram, first load the information, that store, then add, then store, read from file. This is part of CPU burst. And after that wait for input output resources, that is known as input output burst. After that, when you store next information, you can say store increment index, which is write to the file, that work of CPU burst. Again wait for input output, that is input output burst, and again load, store, add, store, read from file, this is work of CPU burst. Wait for input output, that is work of input output burst. You can see first CPU burst, then input output burst, then again CPU burst, then input output burst, CPU burst, input output burst. This is a cycle of input output burst. And next point is, that is CPU scheduler. CPU scheduler selects a process among the processes that are ready to execute and allocates CPU to one of them. And we can say that it is a short-term scheduler. It is also known as short-term scheduler, and or you can say short-term scheduler also known as dispatchers, because dispatcher decides the process to who assigns the CPU process for execution, who make the decisions of which process to execute next. And short-term schedulers are faster than long-term schedulers. Now next point is scheduling criteria. First scheduling criteria is, we have to check what is the CPU utilization. The main objective of any CPU scheduling algorithm is to keep the CPU as busy as possible. Theoretically, you can say CPU utilization can range from 0 to 100, but in real lifetime, we can say that it varies from 40% to 90%, which depends on the load upon the system. Next, throughput. A measure of the work which is done by the CPU is the number of processes being executed and completed per unit of time, that is known as throughput. And we can say that the throughput may change depending on the length or duration of the process. What is the length, what is the duration of the process, and how much time it will be processed, that is the throughput. Next is turnaround time. What is a turnaround time? Turnaround time for a particular process. An important criteria is how long it takes to execute that process. The time which elapsed from time of submission of a process to the time of completion is known as turnaround time. Turnaround time is the sum of times which is spent waiting to get into memory and waiting in the ready queue, and executing in the CPU and waiting for input output. For this, we use formula, means how to calculate turnaround time. We can calculate turnaround time by subtracting arrival time from completion time. By subtracting arrival time of a process from completing time of a process. Now, waiting time. A scheduling algorithm does not affect the time required to complete the process once it starts execution. It only affects the waiting time of a process that is spent by a process which is waiting in the ready queue. And the formula for this, waiting time is equal to total turnaround time minus worst time of CPU. Now next is a response time. What is a response time? In an interactive system, turnaround time is not best criteria. In interactive system, turnaround time is not best criteria. A process may produce some output fairly and continue computing new results while prove out results are being output to the user. And thus, another criteria is the time taken from submission of process of the request until the first response is produced. And this measure is called response time. And response time can be calculated by CPU allocation time when CPU was allocated for first time. That time minus arrival time of a process. When we subtract arrival time of a process from CPU allocated time, then that time, the difference of both, that is known as response time. When process arrive and when CPU is allocated to that process, and in between duration of between from arrival time to CPU allocation time, that is known as response time. Now next is a completion time. The completion time is that time when process stops executing, which means the process has completed its worst time and is completely executed. That is known as completion time. What is a priority? If operating system assigns priorities to processes, the scheduling mechanism should favor the higher priority process. Predictability. A given process which always should run in about the same amount of time under a similar load, that is predictability. Now I am going to discuss about what are the different scheduling algorithms, in which I will discuss only in this video. First come first serve, shortest job first, then priority scheduling, then round robin scheduling, shortest remaining time first, and longest job first and longest remaining time first. It will be discussed in next coming videos. First come first serve means, in this scheduling algorithm, the process which arrives first in ready queue, that will be firstly assigned to whom? Firstly assigned the CPU. In case of tie, for example, P1 process and P2 process both came at a same time, then that is the case of tie. In that case, process with smaller process ID is executed first. It is always non-preemptive in nature. It is always non-preemptive in nature. You cannot be forcefully take the resources from any process. This is a non-preemptive in nature. Advantages: it's a simple, easy to understand. It can be easily implemented by using queue data structure. It does not lead to starvation. Disadvantages: it does not consider priority or worst time of processes. It suffers from convoy effect. What is a convoy effect? In convoy effect, consider processes with higher worst time arrived. In this process, those processes which arrived with higher burst time before the processes with smaller burst time, then smaller processes have to wait. For a long time for longer processes to release the CPU. For example, consider set of 5 processes whose arrival time, burst time are given here. Now, in this question, we have to first of all make a Gantt chart. Gantt chart means, in this we write when processes arrived and when it completed its task according to worst time. Now you can see this is a process 3. It arrived at 0 millisecond. So that's why we can write first of all in this cell P3. It will use it used the CPU for 2 milliseconds. So that's why we write here 2. After that, P1 arrived at 3 seconds. From 2 to 3, this is a gap. This is a idle time of CPU when CPU is freed. After that, we will write P1 because at a 3 milliseconds P1 came, and then 4 seconds it used the CPU and released the resources, and after that who came? P5. At after that P5 came, it uses the process 3 seconds, then 7 plus 3 10, and after that here you can see P2 P4 both are came same time. We can consider here who came first, P2, because we will decide that it uses CPU for longer time as compared to this. When we take P2 first, who takes the CPU for longer time, and P4 who takes the CPU for only 1 second as short time. When we give the preference to P2 because it takes the longer time for CPU, this type of case, this type of tie case, that is convoy effect, because short that process who takes the CPU for short time, but CPU has that process has to wait because here we use non-preemptive. So that's why P2 first, then P4 we will use, we will provide the CPU for P4 after at the end, and this type of case is called convoy effect. If scheduling policy is first come first service, we have to calculate completion time, turnaround time, average turnaround time, waiting time, average waiting time. Now you can see here first P1 when it complete his task at 7, so that's why we will write here in complete time 7. P2 when it complete its task at 13, we write here 13. When will complete P3 task at 2, we write here 2. P4 that will be completed at the 14 seconds, we write here 14. P5 will complete his its task at the 10 seconds, we write here 10. How to calculate total turnaround time? We can calculate total turnaround time by subtracting arrival time from completion time. 7 minus 3 4, 13 minus 5 8, 2 minus 0 2, 14 minus 5 9, 10 minus 4 6. When we add all these numbers we will get 29. This is the total turnaround time. Now waiting time. How to calculate waiting time? For this we use the formula turnaround time minus worst time. 4 minus 4 0, 8 minus 3 5, 2 minus 2 0, 9 minus 1 8, and 6 minus 3 3. When we add all these values we will get 16. Now this is a total waiting time. Average turnaround time, that will be calculated by this method. Add all the values of turnaround time, divide by number of processes. We will find out 5.8 unit. Average waiting time, add all the waiting time, divide by 5, we will get 3.2 waiting unit. This is the average waiting time. This is the method. This question is solved by first come first scheduling algorithm method. Now second is a shortest job first. In this algorithm, out of all the available processes, CPU is assigned to the process having smallest burst time. Having smallest burst time. In this case, in case of tie, here in case of tie, it is broken by first come first service scheduling. Now next, what is the shortest job scheduling? Shortest job first, that will be divided into two parts. First part non-preemptive mode, second part preemptive mode. In preemptive mode, we will use shortest run time first algorithm. And preemptive mode, it can be used in both preemptive or non-preemptive mode. And in preemptive mode, shortest job is known as shortest remaining time first. Now, what are the advantages if we use shortest remaining time first? It is optimal and it gives the grantees minimum average waiting time. It provides standard for the other algorithm since no other algorithms can be performed better than it. What are the disadvantages? It cannot be implemented practically because burst time of a process that cannot be known in advance. So we cannot be use it in practically. It leads to starvation because in this we can be use preemptive mode and for process with larger burst time, and priorities cannot be set for the processes with the largest burst time have poor response time. Those processes with the largest burst time have poor response time. Now here I am going to take an example for solving this method for using this algorithm. Here we have given 5 processes and there these are the arrival time of these processes and these are the burst time of a CPU. And if CPU scheduling policy, shortest job non-preemptive, shortest second, shortest job preemptive, find the average waiting time and average turnaround time. First of all, in this case, I will solve shortest job non-preemptive. The Gantt chart for this, first of all, you have to see who came first. At 0 arrival time P4 came. It uses the CPU for 6 seconds. After that, who came first? Now you have to go to first. Process P1. Who came? Who came P1? That uses that uses only 1 second. So that's why here we write 6 plus 1, 7. After that, who came? You can see here why we use why we use P1 first, because when process came at 3, it uses only for 1 second. When process P2 came, it uses CPU for 4 seconds. When process P3 came after 0 second, it uses the PC for 2 seconds. When P5 came, it uses CPU for 3 seconds. Who use CPU for shortest time? Whose job is shortest? Who use shortest job first? P1. So that's why here P1. After that 4, 2 and 3. Now after P1, process 2 and P3. P2 is P2 process used CPU for 4 seconds, but P3 process who uses CPU for 2 seconds only. And at 4, after 3 milliseconds, who came? P3. So that's why we write here P3. P3 uses for 2 seconds. 7 plus 2, 9. After that, you can see 4 and 3. 1 and process P2 and P5. Both are came already in ready queue. But they are waiting for resource free. For waiting for freeing of resource. We have to decide who use for short time CPU. P5 use for short time as compared to P2 because P2 used for 4 seconds and P5 used for 3 seconds only. So that's why we write here 5 P5 process, 9 plus 3 12, and after that 12 plus 4 16. This is a Gantt chart of shortest job first non-preemptive. Now you have to find total turnaround time. How to calculate completion time? That is P1 is completion time 7 minus 3, that is 4, and after that P2 16 minus 1 15. Now next P3 9 minus 4 5. Next 6 minus next P4 6 minus 0 6. P5 12 minus 2 10, and add 40. Average turnaround time 40 divided by 5, that is 8 unit. Waiting time. Subtract worst time from completion time. Completion time is 4 minus 1 3, 15 minus 4 11, 5 minus 2 3, 6 minus 6, that is 0, 10 minus 3, that is 7. When we add all these numbers, all these values, that is 24. When we divide 24 by 5, then we get average waiting time, that is 4.8. Now next case is shortest job first by preemptive method. Now how to make Gantt chart? First of all, at the 0 second P4 arrived. After P4 arriving, P2 arrived at 1 second. So that's why we write here P2. When we write here P2, then we see that next process came at 2 seconds. So here we cut 4 out of 4, 2 seconds used by P2 and 2 seconds remaining. It will be used after some time. 1 plus 2 3. Now again you can see at the 3 seconds P1 reached. It uses only 1 second, so that's why it cut and 0 came. 3 plus 1 4. At 4 second who came? P3. But here you can see P2 already waiting for resource free up first, and both can use resource for 2 seconds. So who come first? P2. Who wait? P2. So that's why P2 first use the CPU, and when it uses 2 seconds, it will release CPU. After that P3 use, because you can see P5 will be used for 3 seconds. When we compare both, 2 seconds is less than 3 seconds. So that's why here we write P3. 6 plus 2 8, and at 8 second P5 came and it will use for 3 seconds, and when it will use, after that who will be used? P4, because it needs 5 seconds, so that's why it will use at last. 11 plus 5 16. Now you will find average turnaround time. You can see here total time of P1 4, P2 6, P3 8, and P4 16, P5 11. Now subtract their arrival time, and you will find average turnaround time, average waiting time, completion time minus worst time. You will find 3.8 unit, that is the average time. You can compare it that when you use shortest job non-preemptive, then average turnaround time is 8 unit. While we use shortest job first preemptive method, then its average turnaround time will be reduced, that is 7 unit. And average waiting time is also reduced when we use shortest job preemptive method. Now next point is next algorithm we will discuss, that is priority scheduling. In this, out of all the available processes, CPU is assigned to that process who having highest priority. In case of tie, it is broken by first come first scheduling method. Priority scheduling is divided in two parts, non-preemptive mode or preemptive mode. It can be used in both mode. Advantages: it considers the priority of process and it allows the important processes to run first. Then second, priority scheduling in preemptive mode, it is the best suited for real-time operating system. When we use in real-time operating system, then this method, priority scheduling in preemptive mode, is the best method. You should be keep in mind that point. When we are in real-time operating system, then we can use priority scheduling in preemptive mode because it is the best suited for real-time operating system. There is some advantages, but with this there are some disadvantages. Processes with lesser priority may starve for CPU. There is no idea of response time and waiting time. And these are the some note. First, the waiting time for process having highest priority will always be 0. When we consider highest priority, then we will always take 0 as a highest priority in preemptive mode case. And waiting time for the process having highest priority may not be 0 in non-preemptive. In preemptive case, we will take 0 as a highest priority, and in non-preemptive case, we will not take 0 as a highest priority. Now third, the average time of all processes is the same. Arrival time will be same for all the processes and all the processes become available. For example, this is the example of non-preemptive and preemptive CPU scheduling policies for priority scheduling method. In this question, we have given 5 processes. These are the arrival time, these are the burst time, and this is given priority of all the processes. Now, I am going to start first case, that is priority by non-preemptive mode. You can see both of the Gantt chart. What are the difference between priority with preemptive Gantt chart? In priority with the non-preemptive mode, first of all, when P1 arrived at 0 second, it uses CPU for 4 seconds. It take whole time, and when it complete its task, then it release the CPU. And after that, who came P2, P3, P4, P5. But who uses CPU next priority? You can see here P4 and P5 have given highest priority. in a non-preemptive case, we cannot be take 0 as a highest priority. We can take highest priority with highest number. So here you can see P4, P5 both came at same time, but we can give here first preference to according to first come first service method. So we can give P4 we will give to P4 first preference. So that's why P4, we will write here P4 and it will use 5 seconds CPU, and after that it release the CPU. Then we write P5 because second preference given to P5 after the P4, and 9 plus 2 11, and after that who will remain? P2 and P3. You can see here next smaller number by after 5, that is 4. So that's why we give P3 to preference. 12 second 1 second it will use CPU and then release, and then at the end we P2 will be use the CPU for 3 seconds. And this is the Gantt chart of priority with non-preemptive mode. Now priority preemptive method means wipe forcefully. Now for, at the 0 second P1 came, it uses only for 1 second, and when it uses for 1 second, here write 3. After that who came at 1 second? P2. It will uses only 1 second because to at the 2 second who will came? P3. So that's why we write here P3. And after P3 who came at the 3 second? P4. We write here P4. It will use after 4 second after at the, because this time is time will be finish because it is method of preemptive forcefully. P3. After P3 P4 used CPU for 5 seconds. Then who will came? According to priority, you can see here P4 maximum priority as compared to P4 and P5 both have the same priority, but we can take first come first method. So that's why we P4 and after that P5 use this CPU for 2 seconds, and then again who will use P2 because its burst time is smaller and its priority is higher. Priority is higher from P1, so that's why P2 will be right here. It will use 2 seconds, and at the end P1 will be used for 3 seconds. That is total 15 seconds for completion of task of P1. You can see in non-preemptive P1 can complete his task with 4 seconds, while P1 can be work his its by 15 seconds. After 15 seconds means P1 has to wait for 12 seconds, while in a non-preemptive case it do no need to wait for any time, any seconds. Now after that you can find average total turnaround time, same method. Average waiting time, same method. You can solve it, and you can see difference when we use non-preemptive method, whether P1 have to wait only 0 second, but its average turnaround time is 8.2 units, while in preemptive case its average turnaround time 7.4 as compared to its less, and average waiting time 5.2 and its average time wait 4.6. It will also reduced as compared to preemptive non-preemptive mode, priority non-preemptive mode. Now next method is Round robin scheduling. This is most important topic exam point of view. Round robin scheduling. CPU is assigned to process on the basis of first come first service for a fixed amount of time. Here we use first come first service method with the fixed amount of time. And this fixed amount of time is called as time quantum or time slice. Means, for example, 20 second we have to use total, we have a total time 20 second of CPU we can use. After that another person can use that CPU, and 20 minutes we can use this CPU, but we have a 5 processes. We have total 5 processes and we have to complete within 20 seconds all the task. So we can do it. We can divide this time with the equal time division. For example, we can take it 4 minutes. We can give each and every process 4 minutes. That can be used this CPU. But this is the maximum time. But we have to decide minimum time use of CPU. We can take 1 second, we can take 1 minute, we can take 2, 3, anything. But within 20 minutes we have to complete all tasks. Now, after the time quantum expires, running process is preemptive and sent to the ready queue. Then processor is assigned to the next arrived process. It is always preemptive in nature. In round robin, we use the preemptive mode by default. You can see this figure, round robin scheduling and first come first service scheduling with preemptive mode. First of all, process will be in ready queue, then select a process. And when we select a process, then it compare. Worst time is less than time quantum, yes. Then execute till completion and terminate. But if worst time is greater than time quantum, then no, then it will be execute for only time quantum time. And time quantum expires, then it will go this then process execute completely after again going by ready queue. When it go back into ready queue, then again check worst time is less than quantum time, then it will be execute till completion, terminate. But this process will be completing when it complete its total execution. You can see here time quantum expires and it check process executed completed or not. If not, then it go into ready queue. If completed, then yes, then it will be terminate. Then it will go into terminate state. Now next, round advantages. What are the advantages of this method, this algorithm? It gives a best performance in terms of average response time. It is best suited for time sharing system, client server architecture and interactive system. What are the disadvantages? It leads to starvation for process with the largest burst time, as they have repeat cycle many time, because we have to repeat many time till burst time can be finished. Its performance heavily depends on the time quantum. Priority cannot be set here for the processes, and we should be keep in mind that with decreasing the value of time quantum, number of contexts which is increases. If we take time more, time quantum's value decrease, then number of context switches can be increased and response time will also decrease. Third, chances of starvations also decrease. The smaller value of time quantum is better in terms of response time. You should be keep in mind that smaller value of time quantum is better in the terms of response time. Second, with increasing the value of time quantum, number of context switches decreases. When we increase time quantum, then number of context switching that will be decreased. And on the other side, response time also increase. Chances of starvation also increases. This is the most important point, that when we decrease value of time quantum, then number of contexts which is increase, response time decrease, chances of starvation also decreases. And this method is best for the response time. While on the other hand, when we increase the value of time quantum, the number of contexts which is decreases, response time also increases, chances of starvation also increases. Higher value of time quantum is better in the terms of number of contexts switch. Now next important point, when the with the increase in the value of time quantum, when we increase time quantum's value, round robin scheduling tends to become first come first service scheduling. It convert into first come first service scheduling. And second, when time quantum tends to infinity, round robin scheduling becomes first come first scheduling. Fourth important point, the performance of round robin scheduling heavily depends on the value of time quantum. The value of time quantum should be such that it is neither too big nor too small. ना ही बहुत ज़्यादा हो, ना ही बहुत कम हो. Now next, for example, we have given these 5 processes: arrival time, burst time. Now we are going to start its making Gantt chart. Before going to start Gantt chart, we should be take see here first of all what processes will be in ready queue. First, we start from P5, last process. From P5, after P5 we use P1 because P1 came at 0 millisecond. Then P2, you can see P2 and P5 both uses same time of CPU. Now here we can use process 2 first, then process 5 Q, because according to first come first service. After that you can see P4. After P5, P4 who use 2 seconds, and P1 that will be used also 2 seconds. You will give you can see here P4, then you will write P1 because P4 use 2 seconds, P1 use for 3 seconds. Then you give first preference P4. After that P1. Then again you can see when P1 use it, it remains time 1 second. And you can see P3, it also used for 1 second. You give next CPU for P3 because P1 already used it. And after P3 you can see P2 2 seconds and P1 1 second. You can write here P2 first, then P1 because P1 already used it, and turn off P2 first, then P1. Now you have to make Gantt chart. First P1 start here, then it used for 2 seconds. After 2 seconds P2 came, it uses for 2 seconds, and then because time quantum is 2. So that's why each and every process can use for 2 seconds. After that P3 came. P3 use it only 1 second because here burst time is 1. So that's why here 4 plus 1 5. After that P1 again came and 2 second use it. 5 plus 2 7. After that P4 came. It uses for 2 seconds. And after that P5 came, used for 2 seconds. Came P2, used for 1 second. Then again P1 came, used for 1 second. And again at the last P5 came, it uses for 1 second. Now you can find arrival time and average turnaround time and average waiting time. Now next point is multiprocessor scheduling. What is a multiprocessor scheduling? Its main focus on designing the system's scheduling function. Its main focus on designing the system's scheduling, which consists of more than one process. Multiple CPU share the load sharing in the multiprocessor scheduling so that various processes run simultaneously. Multiple processor scheduling, its main focus on to design such type of system scheduling function which can consist of more than one processor and in which multiple CPU processors share the load in multiple processor scheduling so that various processes can be run simultaneously. In general, we can say that multiple processor scheduling, which is complex as compared to single processor scheduling. In multiprocessor scheduling, there are many processors, they are same. We run any process at any time. The multiple CPUs in the system are in the close communication. Multiple CPUs in the system, they are in the close communication, which shares a common bus, memory, other peripheral devices. So we can say that system is tightly coupled and these systems are used when we want to process a bulk amount of data, and these systems are mainly used in satellites, weather forecasting, etc. Now next point is real-time scheduling. What is a real-time scheduling? Real-time scheduling is divided in two parts: soft real-time scheduling and hard real-time scheduling. Soft real-time scheduling means when does not guarantee when a critical real-time processes will be scheduled. On the other, hard real-time scheduling means in which processes must be scheduled before deadline. That is the hard real-time scheduling. Now next is a RM, rate monotonic scheduling. Monotonic scheduling, it's a priority algorithm. It is a priority algorithm and which belongs to the static priority scheduling category of real-time operating system. It assumes that deadline of a periodic task is the same as its period. And these approaches are not new, and these being used by NASA, for example, on the Apollo space missions. And the last point is EDF, that is known as earliest deadline first CPU scheduling algorithm, which is a dynamic priority scheduling algorithm which used in real-time operating system to place processes in a priority queue. Whenever a scheduling event occurs, then task finishes, new task released, etc. The queue will be searched for the process which can be closest to the deadline. These are the topics of today's video. Now, if you like my video, please like and share my channel with your friends so that they can take benefits from this video. and this video is most useful for BSc, BCA, BTECH, MSc, MCA, MTECH students, UGC students, GATE students who wants to give a competitive any type of competitive exam. They can learn from this video about the operating system and their most important algorithms. If you like, then please like and share my channel, and don't be forget my channel, subscribe and click on bell icon. Thank you.